On the Geometry FSA, these are the three formulas you will need to solve any volume problems. The three formulas are given to you, so you won't need to memorize them, but they will only help you if you know how to use them. Now, the first thing I would like to point out is that the capital B in these formulas stands for area of base. Do not make the mistake of confusing it with the lowercase b, which stands for base. You also need to know what shapes these formulas apply to. The first formula, volume equals area of base times height, is used for prisms. You will mainly use this formula on rectangular prisms, triangular prisms, and cylinders. The second formula, volume equals 1/3 area of base times height, is used on pyramids and cones. The third formula is used for a sphere. Now let's take a look at our first problem. Miguel fills a ball with air. The ball has a radius of 9 inches. Miguel has already put 1200 cubic inches of air in the ball. How much more air in cubic inches will it take for Miguel to fill the ball completely? Round your answer to the nearest hundredth. As we could see from our picture, the radius is given to us. The radius is 9 inches. Now first we're going to need the formula for the volume of a sphere, which is volume equals 4/3 times pi times radius to the third power. Since we know that the radius is 9, let's substitute that value into the formula. Now from there, let's follow the order of operations and first do 9 to the third power. 9 to the third power is going to give us 729. Now we're going to multiply 729 times 4 and times pi, and that's going to give us 2,916 pi over 3. Now we could simplify the fraction 2,916 over 3 by dividing those two numbers. So when we divide 2,916 by 3, we're going to get 972. Now for our final step, let's multiply 972 times pi, and that's going to give us approximately 3,053.63 cubic inches. Now that number represents the volume of the entire ball, but that's not our answer because that's not what we're looking for. We're not looking for the volume of the entire ball. We're looking for how much more air does Miguel have to put in the ball. So if Miguel has already put 1,200 cubic inches of air into the ball, what we could do is take the volume of the entire ball and subtract from it 1,200. The remaining amount will be the amount of air that Miguel needs to fill the ball with air with. So when we subtract those two numbers, we're going to get 1,853.63 cubic inches, and that is our answer. That is how much more air Miguel needs to put into the ball. Question number 2. A square pyramid has a volume of 268.8 cubic inches. Each edge of the base measures 8 inches. What is the height of the square pyramid? We're going to need the formula for the volume of a pyramid. So the formula is volume equals 1/3 times area of base times height. Now, we have a square pyramid, so that means that the base of our pyramid is a square. And how do we get the area of a square? We get the area of a square by multiplying length times width. So we're going to replace the capital B with LW to represent the length and the width. Now we're going to substitute into our formula the values that we know. We know from the question that the volume of the pyramid is 268.8. So let's substitute that into the formula for V. And then we know that the length and the width of the square base is 8 and 8. So let's also substitute those values. Now from there, let's start simplifying our equation. Let's start with multiplying 8 times 8, which is going to give us 64. Now we could, for our next step, we could just get 1/3 of 64 by dividing 64 by 3, but that's going to give us a decimal. And a better way to get rid of that 1/3 is to multiply both sides by the reciprocal of 1/3, which is going to be 3/1. So let's go ahead and multiply both sides of the equation by the reciprocal. And when we multiply both sides by 3/1, That's going to cancel out the fractions on the right-hand side of the equation. On the left-hand side, we're going to multiply 3 over 1 times 268.8, which is the same as multiplying by 3. And that's going to give us 806.4 equals 64h. We're still trying to solve for h, so that means that we have to move the 64 or get rid of it and move it to the other side of the equation. We're going to do that by dividing both sides of the equation by 64. When we do that, 806.4 divided by 64 is going to give us our answer, which is that the height of the pyramid is 12.6 inches. Question number 3. If a sphere and a cylinder both have the same volume and the height of the cylinder is 5 inches, what is the radius of the sphere? Let's begin by getting the formulas for the volume of a sphere and the formula for the volume of a cylinder. Now, regarding the formula for the volume of a cylinder, make sure you remember that the capital B stands for area of base. So the base, you have to realize that the bases of a cylinder are circles. And how do we get the area of a circle? We get the area of a circle by multiplying pi times radius squared. So because of that, we're going to replace the capital B in the formula with pi r squared. Our next step is going to be to substitute the values that we know. We know that the height of the cylinder is 5 inches. We know that because they give it to us in the question. So let's go ahead and substitute the number 5 for h. Okay, now that we have that, let's go to the next step. The question says that the volume of the sphere is the same as the volume of the cylinder. If the volume of both solids are equal to each other, that means that we can make these equations equal to each other. We need to do that in order to be able to solve for the radius of the sphere. Now in this equation, I want you to realize that on both sides of the equation we have the variable r. On the left hand side it says r to the third power. On the right hand side it says r to the second power. So what I'm going to do is eliminate the r's so that we only have one r in our equation. And we could do that by dividing both sides of the equation by r to the second power. If we divide both sides of the equation by r to the second power, on the right hand side the r's cancel out. On the right hand side the r to the second power cancels out. On the left hand side, when you divide r to the third power by r to the second power, you'll be left with r to the first power in the numerator. So with that move, we got rid of all the extra r's. Now we only have one variable, r to the first power. And in order to solve for that variable, we just got to move everything that's on the left-hand side of the equation that's not r to the right-hand side of the equation. So let's start by moving the 3. And the way we're going to move the 3 is by multiplying both sides of the equation by 3. When you multiply both sides by 3, on the right-hand side, you're going to get 15 pi. We're still trying to get r by itself, so next let's move pi from the left-hand side to the right-hand side. We're going to do that, or better said, let's get rid of pi. And the way we're going to do that is you could divide both sides by pi. When you divide both sides by pi, the pi's are going to cancel out. Okay, now we have 4r equals 15. For our last step, we're going to divide both sides of the equation by 4. And that's going to give us r equals 15 divided by 4. When you divide those two numbers, that's going to give us our answer. The radius of the sphere is 3.75 inches. Question 4. What is the difference in volume between the two cones shown below? Okay, so this is a pretty straightforward question. In order to find the difference in volume, what we're going to do is find the volume of the blue cone, then find the volume of the red cone, and then we just subtract the two volumes. So let's start by getting the volume of the blue cone. We'll use the formula for the volume of a cone, which is volume equals 1/3 area of base times height. Since the base is a circle, we're going to replace the capital B with pi r squared. Now let's substitute the values that we know. Since the diameter of the cone is given to us, the diameter is 11 millimeters. but we don't need the diameter, we need the radius. So we have to get the diameter and divide it by 2. So 11 divided by 2 is 5.5. That's going to be the radius of the blue cone. Let's substitute those values into the formula. So the radius of the blue cone is 5.5 and the height of the blue cone is 15. Now that we've substituted those values, let's follow the order of operations. First, we're going to do 5.5 to the second power. 5.5 to the second power is going to give us 30.25. We're going to multiply 30.25 times 15, and that gives us 453.75. Now, when we multiply 453.75 times 1 and times pi, and then divide it by 3, we're going to get 453.75 pi over 3. Now, when you calculate that in your calculator, you're going to get the answer for the volume, which is going to be 475.17 cubic millimeters. Again, in your calculator, you have to multiply 453.75 times pi, and then whatever that gives you, the product, what the answer gives you, you're going to divide it by 3. Now let's follow the same steps for the red cone. Again, we start with our formula, and we're going to substitute that capital B with pi r squared because the base is a circle. Now, again, they give us the diameter. The diameter of the red cone is 6, so we got to divide it by 2 in order to get the radius. That means that the radius is 3. So let's substitute the radius and the height into the formula. And now let's follow the order of operations, beginning with 3 to the second power, which is going to give us 9. And then we're going to do 9 times 12. And that's going to give us 108 pi over 3. To get our final answer, we're going to multiply 108 times pi, and whatever that gives you, divide it by 3. So the volume of the red cone is 113.1 cubic millimeters. Now for our final step, we need to get the difference in volume between the two cones. Difference means subtract. So we're going to subtract the two numbers, and that's going to give us our final answer. The difference in volume between the two cones is 362.07 cubic millimeters. Question number 5. The volume of the red sphere is 1,332 pi greater than the volume of the green sphere. What is the radius of the red sphere? Okay, so to begin this problem, we're going to need the formula for the volume of a sphere. And since we already know the radius of the green sphere, the radius is 9, let's plug that into the formula. I'm going to follow the order of operations and do 9 to the third power, which gives me 729. Now when I multiply that times 4, I get 2,916 pi over 3. Now let's finish that off and get the volume of the green sphere by multiplying 2,916. Or I'm sorry, let's not multiply it times pi. Let's leave our answer in terms of pi, and I'll show you why in a second. Let's simplify 2,916 over 3 by dividing those two numbers. So we're going to divide 2,916 by 3, and that's going to give us the volume of the green sphere, and we're leaving our answer in terms of pi. So the volume of the green sphere is 972 pi cubic inches. Leaving our answer in terms of pi means that we do not multiply times pi. We just leave pi in our answer. Okay, the reason that I left my answer in terms of pi has to do with this question, the way it's worded. What the question is saying is that the volume of the green sphere, if we add 1332 pi to it, that will give us the volume of the red sphere. That's what they mean in the question when it says in the very first sentence, the volume of the red sphere is 1332 pi greater than the volume of the green sphere. Okay, so that's why I left my answer for the volume of the green sphere in terms of pi. So let's use that information to get the volume of the red sphere. So we're adding the volume of the green sphere, which is 972 pi plus 1332 pi. And that's going to give us the volume of the red sphere. Now when we add those two numbers, what we're doing is we're adding like terms. We're just going to add the coefficients, which are the numbers in the front. We're going to add 972 plus 1332, and we're just going to leave the pi symbol in the back. So when we add that, we're going to get 2,304 pi. That's the volume of the red sphere. All right, so now we have the volume of the green sphere and we have the volume of the red sphere. And keep in mind that what we're looking for in this question is what is the radius of the red sphere? Well, the reason we did this is because now that we know the volume of the red sphere, we could use the formula for the volume of a sphere to figure out the radius of the red sphere. Okay, so let's substitute into the formula the volume of the red sphere, which we already have. Okay, so we're substituting 2304 pi into the formula. Now from there, we're going to solve for r. Our first step is going to be to get rid of that fraction. We're going to get rid of the 4 over 3 by multiplying both sides of the equation by 3 over 4. When we do that, on the left-hand side, we're going to multiply 3 times 2304 pi. And then when we multiply 3 times 2304, we're going to divide that by 4. So again, on the left-hand side, we're going to multiply 3 times 2304 and then divide by 4. And that's going to give us 1,728 pi equals pi r to the third power. Now let's get rid of the pi. As you can see, we have pi on both sides of the equation. The way we could get rid of it is if we divide both sides of the equation by pi, the pi's cancel out. So now our equation is r to the third power equals 1728. Now the way to get rid of that exponent, that 3 in the exponent, we're going to get rid of it by doing the opposite of raising a number or a variable to the third power. We're going to get the cube root of both sides. We're going to get the cube root. That means what number to the third power equals 1,728. Now your calculator or your iPhone will have a button for getting the cube root. If you don't know how to get the cube root of a number, make sure to ask your teacher. But when you get the cube root of 1,728, that'll give us our answer, which is that the radius of the red sphere is 12 inches. Question number 6. Each dimension of the large cylinder is 75% greater than each dimension of the small cylinder. How much greater is the volume of the large cylinder than the volume of the small cylinder? Leave your answer in terms of pi. Okay, so to do this problem, you have to remember how to work with percents. It's not difficult, but a lot of students tend to forget, or maybe they didn't learn correctly the first time. So what I'm going to do is I'm going to get each of the dimensions of the pink cylinder and use them to calculate the dimensions of the purple cylinder. That's the first thing I'm going to do. So let's get the diameter of the pink cylinder. The diameter is 8 centimeters. If I want to know what is a number 75% greater than that number, there's 2 ways to do it. In my opinion, the easiest way to do it is to multiply 8 times 1.75. That's going to give me a number that's 75% greater than 8. So when I multiply 8 times 1.75, that's going to give me the dimensions of the diameter of the purple cylinder, which is going to be 14. Now I'm going to follow the same process for the height of the pink cylinder. I'm going to use the height of the pink cylinder, which is 20. I'm going to multiply it times 1.75, and that's going to give me a number that's 75% greater than 20. That number is 35, and that number is the height of the purple cylinder. Okay, now that I have the dimensions of both cylinders, let's continue working on this problem. Let's get the formula for the volume of a cylinder. Volume of a cylinder is area of base times height. And since a cylinder has a circle in the base, I'm going to replace the capital B with pi r squared. Now starting with the pink cylinder, the diameter is 8. So that means that the radius has to be half of 8. The radius is going to be 4. And the height we already know is 20. So I'm going to substitute those values into my formula. So now I have the radius and the height in the formula. Now let's just solve that. And remember, they want us to leave our answer in terms of pi. So I'm not going to multiply times pi. I'm just going to do 4 to the second power. And that's going to give me 16. And then I'm going to multiply 16 times 20. and that's going to give me 320. So the volume of the pink cylinder in terms of pi is 320 pi cubic centimeters. Now let's do the exact same process for the purple cylinder. I'm going to start with my formula, and I'm going to make sure to substitute for capital B. I'm going to substitute pi r squared. Now they give us the diameter of the purple cylinder. The diameter is 14, so I got to divide it by 2 in order to get the radius of the purple cylinder. So obviously the radius is going to be 7. Let's substitute the radius and the height of the purple cylinder into the formula. And let's start with our exponent. So we're going to do 7 to the second power, which is going to give us 49. Then we're going to multiply 49 times 35. And that's going to give us the volume of the purple cylinder, which is going to be 1,715 pi cubic centimeters. Okay, so now that I have the volume of the pink cylinder and the volume of the purple cylinder, I need to figure out the answer to the question. So let's look at the question again. The second sentence tells us how much greater, or asks us, how much greater is the volume of the large cylinder than the volume of the small cylinder? In order to find that out, we need to subtract the two numbers. So 1,715 pi minus 320 pi is going to give us our answer. So 1,395 pi cubic centimeters. That's how much greater the purple cylinder is than the pink cylinder. Question number 7. The square pyramid and the cone shown below both have the same height and volume. What must be the radius of the cone? Round your answer to the nearest hundredth. Okay, so we're looking for the radius of the cone, and both the pyramid and the cone have the same height as well as the same volume. So let's begin by getting the volume of the pyramid. So we have the formula for the volume of a pyramid. Volume equals 1/3 area of base times height. Now, what shape is in the base of our pyramid? It says in the question that we have a square pyramid. That means that the base is a square. And how do we get the area of a square? We get the area of a square by multiplying length times width. So let's replace our capital B with LW. Okay, now we know the height of our pyramid and we know the length and the width of our pyramid. So let's substitute those values into the formula. And now let's work that out. If we multiply 12 times 12 times 10, we're going to get 1,440. Now let's divide that by 3, and that gives us the volume of the pyramid. The volume is 480 cubic inches. Now that we know the volume of the pyramid, let's go to the volume of the cone. We start with the formula for the volume of a cone. And since the base of a cone is a circle, we're going to replace the capital B with the formula for the area of a circle, which is pi r squared. Now, do we know the radius of the cone? No, we do not. That's what we're looking for. That's the question. Do we know the height of the cone? Yes, we do. In the question, it says that the height of the cone is the same as the height of the pyramid. So that means that the height of the cone is 10. Do we know the volume of the cone? Yes, we do, because in the question, it says that the volume of the pyramid and the volume of the cone is the same. So let's substitute those two values into our formula. Okay, so we substituted the volume and we substituted the height. Now we could go ahead and solve this. Let's start by getting rid of the fraction. Let's get rid of the 1/3 by multiplying both sides of the equation by the reciprocal of 1/3, which is 3/1. On the right-hand side, that's going to cancel out the fractions. On the left-hand side, 3/1 times 480 is going to give us 1440. So now our equation is looking a lot easier. But we're still trying to get R. We're still trying to solve for R. So next step is let's divide both sides of the equation by 10. So when we divide 1,440 by 10, that's going to give us pi r squared equals 144. Now, let's take that equation, and again, we're trying to solve for r. So we need to move pi to the other side of the equation in order to get r by itself. So when we move, or the way that we move pi to the other side is by dividing both sides of the equation by pi. When we do that, pi cancels out on the right-hand side. On the left-hand side, you're going to have to work that out on a calculator. Divide 144 divided by, and make sure to hit the pi button on your calculator. When you do that, you're going to get r squared equals approximately 45.8366. But we're not looking for r squared. We're looking for just r. So we need to get rid of that exponent. The way we're going to get rid of that exponent is by doing the opposite of squaring a number, which is getting the square root of a number. So we're going to square root both sides of our equation, and that's going to give us that the radius of the blue cone, or the radius of the cone, is approximately 6.77 inches, and that is our answer. Question 8. Solid A and solid B are congruent. Some of the dimensions of solid A are shown below. If the volume of solid B is 324 cubic inches, what is the combined height, h, of solid B? So we're looking for the combined height of solid B. If you look at the picture all the way on the right, that shows you what we're looking for. We're looking for the height. That includes the height of the rectangular prism on the bottom and the pyramid on the top, the combined height. Now, one thing I want to make sure that you realize is that the question says that solid A and solid B are congruent. That means they're exactly the same. That's important to know because that means that the volume and the dimensions of one of the solids is going to be the same as the volume and the dimensions of the other solid. Okay, so that's going to allow us to use a lot of the information they've given us to solve this problem. All right, so make sure you realize that the volume of the rectangular prism plus the volume of the pyramid is going to equal the volume of solid A. We got to get the bottom and the top, the volume of the bottom and the volume of the top, and add them together, and that'll give us the entire volume of solid A. Let's substitute that equation with the formulas for each individual solid. Okay, so for a rectangular prism, the formula for getting the volume is area of base times height. And for a pyramid, the formula for getting the volume is 1/3 the area of base times the height. And they've given us in the question the volume of solid B. Solid B has a volume of 324 cubic inches. But if the two solids are congruent, that means the volume of solid B is also the volume for solid A. That's why I've put that in my equation, that the volume will equal 324. Okay, now let's substitute the values that we have into our equation. We know that to get the volume of a rectangular prism, we have to do length times width times height. And to get the volume of the rectangular prism, to get the volume of the rectangular pyramid on the top, we have to do 1/3 of the length times the width times the height. We know all of those values. We know the length is 8, the width is 4.5, and the height is 6, or at least the height of the rectangular prism is 6. Let's substitute those known values into the equation. The only height that we don't know is the height of the pyramid. Okay, with this information that we've substituted into the formula, that's going to allow us to find the height of the pyramid. So let's start simplifying this equation. On the left-hand side, if you multiply 8 times 4.5 times 6, you'll get 216. And then for the pyramid, if we multiply 8 times 4.5 and then divide our result by 3, that'll give us 12. So that leaves us with a much easier equation here to work with. This is a simple two-step equation at this point where we're trying to solve for h. So let's solve for h by first getting rid of 216 by subtracting it from both sides, which will give us 12h equals 108. And now let's divide both sides by 12, and that'll give us the height of the pyramid, which is 9 inches. Now make sure you realize this is not the answer to the question because the question wants the combined height. I know both are using the letter H. To not make the problem any more confusing than it is, I used H for height, but realize that this is only the height of the rectangular pyramid. Okay, to get our answer for our question, we have to add the height of the pyramid with the height of the prism. Okay, so we're going to add the 6 plus the 9, and that gives us the combined height of the entire solid, which is 15, and that's going to be our answer. The combined height is 15 inches. Question number 9. A full bag of sugar is emptied into a storage container. What will be the height of the sugar in the storage container? Round your answer to the nearest hundredth. Okay, so first of all, imagine this. We have a full bag of sugar and it's in the shape of a rectangular prism. So it's very easy to calculate the volume of that solid because it's a rectangular prism. We're going to pour the contents of the bag of sugar into the storage container. And the question is, once you pour the sugar into the storage container, what will be the height of the sugar? Let's start by calculating the volume of the bag of sugar. Okay, so we get the volume by multiplying length times width times height, and we have all of those dimensions. So let's multiply them, and that's going to give us the volume, which is going to be 69.536 cubic inches. That is the volume of the bag of sugar. Now let's go to the storage container. We're going to use the same formula, which is the formula for the volume of a rectangular prism. But let me tell you what we're not going to use. We're not going to use the height of the storage container because we don't need it. We're not concerned with the height of the storage container. We're concerned with what is going to be the height of the sugar once it's in the storage container. So H is what we're trying to solve for. Do we know the volume of the sugar once it's in the storage container? Yes, we do. It's the same as the volume that we had in the bag. The volume is the same. So I'm just substituting the volume of the sugar, of the bag of sugar. I'm placing it for V because it's going to be the same volume when you pour it into the storage container. The length and the width are going to be the length and the width of the storage container. What we're trying to solve for is the height of the sugar once it's in the storage container. So that's why I have not substituted any value for H. We need to solve for H. Okay, so once we get to this point, it's pretty straightforward. Just multiply 6.4 times 5.2, and that's going to give you 33.28. And now divide both sides of the equation by 33.28, and that's going to give us our answer. The height of the sugar inside the storage container is going to be 2.09 inches. Now we're at our last question, question number 10. The aquarium pictured below is in the shape of a rectangular prism. Currently, the height of the water in the aquarium is 13 1/4 inches. How many more cubic inches of water are needed to fill the aquarium so that the height of the water will be 18 inches? Round your answer to the nearest cubic inch. Now I know students look at this questions like this and immediately see fractions and get intimidated and think that they can't do this. But if you pay attention, you'll see just how simple we can make this problem, even though it has fractions. Okay, so first of all, let's make sure you understand what we need to do in this question and what it's asking us for. Okay, they want to know how much more water do we need to put into the aquarium so that the height of the water will be at 18 inches. So we're not going to use the height of the aquarium at all. What we're going to need is the height that we want the water to be at, okay? We're going to use the height that we want the water to be at, which is going to be 18 inches. If you look at the red outline, okay, in red we have a rectangular prism. And calculating the volume of a rectangular prism is very easy. Just multiply length times width times height. But again, do not use the height of the aquarium. We don't need it. What we need is the height of the water. We need the height of where we want the water to be. So that's what we're going to calculate first. What's the volume of the water where we want it to be? So that's why the height is 18 inches. But then we're also going to calculate the volume of the rectangular prism of where the water currently is. Okay, according to the question, the water is currently at a height of 13 1/4 inches. And in green, you could see outlined a rectangular prism. So we're going to use the dimensions of that rectangular prism to get the volume of where the water is currently at. And we're going to subtract it from the volume of where we want the water to be. When we subtract them, the remaining amount tells me how much more water I need to add to the aquarium. Okay, so now that we've set up our equation and we've set up how we're going to do this problem, let's make some space on the screen here. And let's work with these fractions. And let me show you how simple it is to work with them. Okay, what we're going to do is get each mixed number. A mixed number is when you have a whole number with a fraction next to it. We're going to get each mixed number and change it to an improper fraction. If you forgot what that is, an improper fraction is when the numerator, that's the number on the top, is bigger than the denominator, that's the number on the bottom. Okay, so let's start with 25 and 1/4. And the way we do this is we're going to multiply. We're going to multiply 25 times 4, which is going to give us 100. And then we're going to add the number on the top of that to it. So that's going to give us 101 over 4. You could memorize this process easily because it makes the shape of a check mark. Let's go to the next mixed number and do the same process. So we're going to start by multiplying 10 times 12. That's going to give us 120. And then add the number on the top, and we'll get 121 over 12. Now the 18 is a whole number, but let's change it to a fraction and make it 18 over 1. On the other side, let's do again 25 and 1/4 by multiplying 25 times 4. And then you add the number on the top, so that's going to give us 101 over 4. The next fraction, the next mixed number I should say, is we're going to do the same process. 10 times 12 is 120. Add the number on the top, you get 121 over 12. The denominator always stays the same when you do this process. And for the last mixed number, we're going to multiply 13 times 4, that's 52. And we're going to add the number on the top, so we get 53 over 4. Okay, now for our next step, let's multiply each side. Okay, so on the left-hand side, we're going to multiply all the numerators because that's how you multiply fractions. You multiply the numerators times the numerators and the denominators times the denominators. So we're going to multiply all three of those numerators. 101 times 121 times 18. And that's going to give us 219,978. Now let's multiply all the denominators. 4 times 12 times 1. That's going to give us 48. Let's do the same thing on the right-hand side. We're going to multiply 101 times 121 times 53. And that's going to give us 647,713. Let's do the same on the bottom. 4 times 12 times 4. That's going to give us 192. Now, here's some good news. If we had to if we had to do the next step with fractions, that would be very difficult. But luckily, we don't have to do our next step with fractions because they want us to round our answer to the nearest cubic inch. That means round your answer to the nearest whole number. So what I'm going to do to make this easy is just divide. I'm going to change both fractions to a decimal. Okay, so, and could you have done that at the beginning? Sure, you could have. So on the left-hand side, if I divide 219,978 by 48, I'm going to get the following decimal. I'm going to get 4,582.875. Now let's do the same thing on the right-hand side. We're going to divide 647,713 by 192, and that's going to give us 3,373.51. For our last step, we need to subtract these two numbers, okay? And that's going to give us our answer, which is approximately 1,209.365. But the question says round your answer to the nearest cubic inch. That means round to the nearest whole number, basically. So our final answer is going to be 1,209 cubic inches. That's how much water we need to put into the aquarium to raise the water level to 18 inches. On this problem, could you have changed the fractions to decimals from the beginning? Sure, you could have done that as well. That concludes this lesson. Make sure to subscribe to my YouTube channel, Math Discipline. I'm going to be adding more videos on there that will help you review for the geometry FSA.